Algebra. We are starting off the home stretch of the year. We are post-spring break. We have most of April, all of May, a little bit of June to get through the rest of the curriculum. And we start with CO49, multiplying polynomials. So think back to kind of our path leading up to this, Andrea, Sam. We started back talking about just what these different nomials are, right? We talked about standard form. We talked about binomials and trinomials. Here we are. All different types of nomials, okay? Then we went to addition and subtraction. And we got some pretty long nomials here, right? And we talked about how lining up those like terms vertically, leaving spaces for the ones that one nomial has, the other one doesn't, all that sort of stuff there. We got to the multiplying. We talked about the distributive property, right? And now when you've got a monomial times any other nomial, you're just taking whatever's on the outside and distributing it in to everything on the inside, okay? What gets multiplied when you, in like 6x to the fifth times negative 2x cubed, what gets multiplied? The 6 and the negative 2, your coefficients. The base stays the same, and what happens to the powers? They get added, right? We saw this was kind of a combination of PO7 and CO10, where we distributed into parentheses before. We've multiplied exponent expressions before, right? And that's what we got. Then we went to binomials. And because drawing all those lines, if you don't do it in an orderly fashion, can get a little bit confusing. We talked about old man foil, we talked about crab plot, and we talked about the box method. Okay? Now we're on CO49, and you'll notice we're not dealing with a monomial times any other nomial. We're not dealing with a binomial times a binomial anymore. We've got a binomial times a trinomial times a trinomial here. Drawing the lines get to be super confusing, especially based on how some of you write. Okay? In this one, essentially what we're doing is we're still taking this first term, that's 7x, and distributing it into every other term in the second set. And same thing with the negative 4. Okay? But look at all those lines. It's easy to get lost. And then when you've got a trinomial times a trinomial, think about all these jumps that have to happen here. The 4x squared goes into each term in the other set. Then we got the negative 5x as well. How do I do this? It just gets me very confusing. Okay? So the recommended method for multiplying these multinomials is the box method. There aren't any lines to draw. It keeps it very well organized. And you've done it before. Even if you didn't do it for your homework, you were required to do it when we first learned about PO48. So given this first one here, 7x minus 4 and 2x squared plus 4x plus 1, what type of box are we going to be making? What are the dimensions? 3 by 2, okay? And you can put it, those 3 going vertically, 3 going horizontally. Doesn't make a difference. The only thing I'm going to remind you of, again, don't make your box too small. Right? You've got to fit these terms in here with negative signs and exponents. If you're trying to squish them into a small space, it's not going to work out well. I'm going to put my binomial down the side and my trinomial across the top. Okay? So there's my 2 by 3 box. And again, I decided on these dimensions because I've got a binomial. There's my 2, 7x, negative 4. And I've got a trinomial. There's my 3, 2x squared, 4x, and 1. Okay? And now how the box method works is each square is the product of the 2 terms that intersect there, right? So this top left box, we're taking 7x times 2x squared, we get 14x cubed. Right? Going over one, 7x times 4x, is going to be 28x squared. And then 7x times 1 is just going to be 7x. Questions on how I got any of those terms going across the top there? I essentially took this 7x and distributed it into every term in the other set, right? But I didn't draw the lines to do it. We did the box method instead. Keeps it nice and orderly and organized. Okay. Now I go to my negative 4. Negative 4 times 2x squared is negative 8x squared. Negative 4 times 4x is a negative 16x. And negative 4 times 1 is a negative 4. Okay. Now that I've filled out the box, what am I looking for? Nathan.
These things that you can like put together.
Yeah, like terms I can combine. What do you see? Is there anything I can combine with 14x cubed? No, there are no other x cubed terms. So 14x cubed goes down the bottom. Yeah.
No, never mind.
How about my x squared terms? How many x squared terms do I have? Jocelyn.
You have 28 and negative 8.
Right. I got 28x squareds there, negative 8x squareds in that box, that section. How many x squareds do I have total?
2.
You have 28 of something, you take away 8, you've got 20 x squareds left. Okay? This is combining like terms now, so we're adding and subtracting. Remember, a coefficient is just how many of something you have. Whatever x squared is.
I thought you guys multiply.
You multiply to make the box. Once you're in it, then you combine like terms with addition or subtraction. Okay? Just like with Old Man Foil and Crab Claw, right? Those two x terms, we added or subtracted them to combine them. Okay? That's what we're doing here. We did the multiplying. Now we're looking for those like terms we can combine, and when you combine like terms, it's with addition or subtraction. How many do you have? You have 28x squareds, you take away 8, you've got 20 of them left. Okay? For your x's, you've got 7 of them. You take away 16, how many x's remain?
Negative.
Negative 9.
Or negative. I know.
Negative 16 plus 7, 7 minus 16, either way, you get negative 9. And then your constant, negative 4, you can't do anything with. Okay? So here's what Nathan brought up is actually, it can be tricky. It's where a lot of people go wrong with this. Once you fill out the box by multiplying, you then combine like terms with addition or subtraction. Okay? You wouldn't multiply a second time. Right? But there you have it. Okay? Questions? I think hopefully it helps that you've had experience with this before, with foil and crab claw in the box. Now it just gets bigger. Okay? Let's go down and let's do the 3 by 3. Okay? And let's do this the last one here on the page. Your 3 by 3 box, again, don't be shy. I don't give you this much space, just to keep it blank. Okay? Make it hefty. And we got 3 across the top and 3 down the side. A trinomial and a trinomial. It does not matter which one goes across the top, which one goes down the side. So I'll put our 9x to the 4th, negative x cubed, 2x squared down the side, and 5x cubed, 7x, negative 10 across the top. Double check before you start multiplying. Make sure you've got all your signs correct. If you miss a sign, it messes a whole bunch of things up. Okay, so just double check, make sure your sign's correct, and now I can start to multiply. What goes in the top left section here? 9x to the 4th and times 5x cubed. 45x to the 7th. What goes in the top section here? 9x to the 4th times 7x. Nick?
Negative 5x to the 5th.
You're going down? Sorry, I was.
Sorry.
No, it's fine. It's negative 5x to the 6th. Right? 3 plus 3 gives us 6. Negative 5x to the 6th. And then the bottom one, 5x cubed and 2x squared. What do we get? 10x to the fifth. Good. Okay? So your first operation here is you are multiplying. Right? Filling out the rest of these, we're kind of running short on time, so I'll just do them here. We got 63x to the fifth, 9x to the fourth times 7x. Don't forget, this x does have a power of 1, even though it isn't written there. Right? So it's not 63x to the fourth. You are multiplying that x to the fourth by another x. So it's x to the fifth. Then we've got negative 7x to the fourth in the middle box. And at the bottom, 14x cubed. Then our third column now, 9x to the fourth times negative 10, negative 90x to the fourth. Positive 10x cubed. We have those signs canceling out there, so it's positive 10x cubed. And then negative 20x squared. Okay. Now, what can we combine? Anything that can combine with our 45x to the seventh? No. And I'm starting way over here because this answer is going to be long. Okay. How many terms with the power of 6 do we have? Just one. Negative 5x to the sixth. Right? So this is by itself. This is by itself. How many terms with a power of 5 do we have? 2. And they're not next to each other, right? In the first one, they were nice and diagonal. That's not always going to be the case. So we've got this 63x to the fifth and this 10x to the fifth way down here. Okay? Those can be combined. How many x to the fifths do we have in total? Nathan?
73.
Good. Positive 73. So plus 73x to the fifth. X to the fourth. How many x to the fourth terms do we have?
2.
2 of them. Right? These are diagonal. That's nice. How many x to the fourths do we have in all? Andrea? Negative 97. So minus 97 x to the fourth. I'm still going to be scrunched for space now. Here, at the bottom. How many x cubes terms do we have? We've got 2 of them. How many x cubes are there in all? Everybody. 24. 10 and 14 make 24 x cubed. And then our lone x squared term, nothing to combine it with, minus 20x squared. That's the very end. Okay? And this is our answer. Right? There's nothing else we can combine. It doesn't equal anything, so we can't solve for x. This is just a super long polynomial answer that we come up with. Okay? How are we doing? No, you can keep the test. That's all good. Okay, this is homework for tomorrow. CO49. Obviously, work must be shown. And the box method is the work that you want to put in. That's how you math. Like, subscribe, all the things.